Okay, this is just a very quick presentation, just in case we have a 2-hour late start tomorrow, which again we had discussed would probably mean we begin with first hour class and second hour, and then we would pick up with you next time, which may be as late as Wednesday, depending upon this weather. So you had this paper that was handed out to you today, and it's very similar to what we have been talking about as far as these dot diagrams. You can see we still have these same problems or these same molecules that we went over earlier today. So we'll do something very similar to some of them that you see here. For instance, it says CaCl2, but we will draw, for instance, since strontium is in the same column as that of calcium, it will have 2 valence electrons as well. Okay, so there's our Sr, and we'll just do Br. Okay, your example on that front page says this, CaBr2. And what that means is this would look very similar to what this one is, because strontium and calcium, they're both in the same column. Bromine and, excuse me, I wrote the wrong element down. It says CaCl2. Okay, and both of these are halogens, bromine and chlorine. Okay, so we had said when it comes to drawing these, okay, you're going to want to always put carbon in the middle if it's present, and if that's not present, then nitrogen. If neither one of those are present, well then you'd want to put your metals in the middle. So in that case, this would be strontium. And since strontium is in column 2, it just has those 2 valence electrons. Okay, so we said our metals would go in the middle. Now we have this bromine that also is a halogen, so it has 7 valence electrons. So where is it going to get that extra one? Well, it's going to get it from that strontium, because we have 1 electron here. Okay, so 7 of them, 1, 2, 3, 4, 5, 6, and 7. Same thing over here, bromine, 1, 2, 3, 4, 5, 6, and 7. Here we have an octet, okay, and here we have an octet. And notice that strontium does not have any electrons around it, but that's because it's a metal and it donated its electrons away to the bromine. Okay? Because remember, this is an ionic bond. It's a complete transfer of electrons. Okay? Now, an example of what we'd see as a covalent bond, okay, would be that of, for instance, C2H2. This one that we had done earlier. Because what we see happening with that, C2H2, since carbon is present, we're going to put that in the middle. And if you remember from class or lecture time, we went through the process of saying, well, a single bond doesn't work, we'll try a double bond. In that case, that doesn't work either, so we're going to do a triple bond for that. So there's 3 carbon being in column 4, okay? There's its 4 valence electrons, and then another carbon atom that also has 4 valence electrons. So here is our triple bond, because carbon can do that. And then notice we have 2 hydrogens left over. There's one, and then here is the other. Okay? Again, this is a covalent bond because we see a multiple bond that the 2 carbons have with one another, and they are sharing all of them. Okay, so if you were watching this, you have some of them done. That's going to give you a very clear and concise, hopefully, head start. And if you remember the materials that we'd gone over earlier, will certainly help you as well. So some of these you can also look in your textbook. There'll be examples of them as well. And we will catch up to you at a later time. Whether it's tomorrow or Wednesday, we will see you then.